Okay, well, continuing on in chapter 5, we'd gotten down to conditional execution. This involves if statement. And you think about your conditional execution you do in your day-to-day activities. Um, Later on, if I'm hungry, then I'll go eat. Um, if it's time to go home, I'll get in my car and drive home. So our whole life is based upon if statements. Now, sometimes we have a alternative execution. Let's see. That'd be like this example. If this, then this, do this, else do this. Um, if I'm hungry, then I'll eat. Otherwise, I won't. Um, if it is Friday, then I'll go to the store. Else, I won't go to the store. So I don't go to the store on other days. Um, so that's the way the if else works. And this is a code I was looking for somebody else, but I guess I can play with that and modify. Um, let's just do a simple division. Divide numbers A and B. And let's see, I'm going to have answer equals A divided by B. And I'll print my answer. And okay, divide numbers A, B. Again, you cannot have this indentation here. This is an important part of Python, is getting used to that format. Okay, so if I run this, I put in 3 and 4, gives me 0.75. Run it again, I get 3 and 0. And it blows up. So you got a bunch of error messages here, and finally tells us division by 0, which is good, but then you got a lot of this. Let's say I want to anticipate that. So up here, I can do a check. I can say if. Now, you'll notice, unlike other languages, you do not need parentheses around the Boolean condition. So if, and by the way, it doesn't hurt, if you put, if B is not equal, now that's what we're checking here. Wait, that's not equal. Okay, let me do 0, equals 0. Then I'll print cannot divide by 0. Else I'll do this. Okay, so if I run that, now if I put in 3 and I put in 0, no longer does it blow up and give us all those error messages, but I've anticipated what they potentially could put wrong into into the input, and then handle it appropriately. Now the equals is our check for is it equal. If you just put a single equals, see how we get a syntax error? I also got W3 Schools open here. Somewhere. Okay. So for our if statement, to check how if something's equal, you do equals. If something is not equal, you do exclamation equals. Less than equal to, greater than equal to. Now this condition right here will turn true or false. And so when your if statement runs, it's checking to see, hey, is this true? Is this false? And then it'll handle that appropriately. Okay, let's try something a little bit more interesting. Let's write something to calculate pay. And you get time and a half if you work overtime, which is over our 40 hours. So, let's see. We get hours. So input number of hours. And I want to get hourly rate. So say enter hourly rate. And here I got hours equal to, so if I don't want integer. With double. Let's float. And then this one will be hourly rate. Like that. And I'll call calculate pay. I'll pass in hours and hourly rate. So I'm going to have calculate pay. It's hard being off of work and coming back. Even though I was zooming from home and so forth, so I was able to sleep in more and all that. Okay. Now the idea here is that if we're paid like 30, you got 30 hours at, let's say you're getting $6 an hour or $5 an hour. Not very good. Then you'd have 30 times 5 equals 150. If you had, for example, 50 hours, which would have overtime, then you would have the first 40 hours at your $5, and you'd have the other 10 hours of overtime at time and a half, which is $5 times 1.5. That's how you figure time and a half. Well, you can make this pretty complex, but you could just simply do a check here. If hours is less than or equal to 40, then it's just taking your pay is just hours times hourly rate. Nothing exciting. If it's not less than or equal to 40, that means it's greater than 40. So at this point, that's where I want to figure it a little bit differently. I need to figure out how many overtime hours there is. So overtime hours is going to equal to your hours minus 40. So then my pay is going to equal to 40 times hourly rate. Now, if you're wondering why are you hard coding 40? Well, if it's greater than 40, that means no matter what, you're going to have 40 hours at the hourly rate. And then you're going to have your overtime hours. So overtime hours times hourly rate times 1.5. Now you can return the pay, and down here where I calculate the pay, I could have the pay amount equals to calculate pay hours. And then print the pay was pay amount. And it doesn't like something. Doesn't like my comments. Obviously, I'm using the wrong symbol. Pound. Different languages have different comments symbols. Okay, number of hours, put in 30, put in 5, that's should be 150. Except I can't spell. Calculate. Okay, 35, and we got 150, which is what it should be. Now let's try 50 hours. So 50 at 5, it says 275. Well, let's see. $40 times 5 would equal 200. Plus my overtime, which would be 10 hours, times 5 times 1.5. So 200 plus 50, 75, 275. So that checks. So that would be an example of how to calculate your pay, assuming you get time and a half. Now I could check if they put in invalid input here. And sometimes you can put that down here in a while statement, which we'll eventually look at, or loop while construct. And but you could check to see if they put in negative hours. What would negative hours do? So maybe you want to check for that and then handle it appropriately. So there's a lot of purposes for the if-else. Now you can add chain conditionals. A little bit different than what you've seen in other languages. Instead of else space if, it's elif. So for example, let's say I wanted to print your grade. And start new file. Print grade, and I'll be passing in grade, passing in the grade. Now here, I'll say if grade is greater than or equal to 90, print A. Notice how I had the backspace, because it's got to line up, so it doesn't look like other languages. And I'll do an LF, grade is greater than or equal to 80. Print B. Grade is greater than or equal to 70. Print C. And then LF, grade is greater than or equal to 60. Print D. And then your final else will be if all above is not true, then it'll do this. Print F. Okay, so down here, we're going to get our input. So line underscore. Nope, not line underscore, just input. Okay, never mind. Well, I was thinking line underscore. Let's be another language. Input score on test. And grade is equal to float grade. And print grade, grade. And invalid syntax. Oh, def. Forgot def. I was going to say, I didn't think that having a colon at the end was an issue. That's what it seemed to be implying. So sometimes when where it tells you the error is at, it's just not really where the error was. The error was I forgot the def. Or one of the errors. Else if grade is greater than or equal to 60. This is programming though. If you don't got patience, sit there and debug what you typing in wrong, then you're probably in the wrong area. 70. Okay. Let's try one more. 50. Okay, that's working. Now let's talk about it. How this works. Now grade is equal to input, and then I got a prompt here. So that prompts for the input and gets it. It stores it as a string. Then I say grade is equal to float grade. We didn't do this before. I had a different variable for string, like string grade. This time I'm using the same variable name. Well, it basically, you can think of it as recreating a variable. So it's allocating new space in memory for it. Here, the memory that's allocated is for a string. And when I do this casting operation, casting is where you change it to another variable type. I want to change it from a string to a number, specifically float, a number with decimals. Then when I do that, it reassigns that out in memory. So gives a different probably location even, but gives it maybe a different size, different storage for the grade. We don't have to worry about that. But I wanted to point this out because you don't have to have separate variables. And then I call print grade, passing in that parameter. Comes up here, and let's say I put in 70. So how an if, else, elif, and else works is it comes down here. It sees this. It goes and retrieves the value of grade, which is right here, and puts it in here. So it puts 70 in there. And 70 is greater than or equal to 90. That's false. So it skips down to the next portion, and it plugs 70 in for the grade there. It says, hey, is 70 greater than or equal to 80? It's not. That's false. So it comes down to here. And it plugs 70 in for grade, and it says, is 70 greater than or equal to 70? It's not greater than, but it is equal. That's true, which means it'll print this. And then after it gets done running that, it'll drop down to after the if-else statement and do the next line of code. There isn't any, so it returns back to the main program, which again doesn't have any code there either. So that's how that works. You can have multiple lines in here. You just have to indent them appropriately. You can have nested conditionals. See here? Within this else, we have another if statement. It's a little bit different than the concept of elif. Elif means they're on the same level. Trying to think of an example on that. Probably can't think of one. Nah, I can't think of one. Okay, recursion. Not a good one anyway. So recursion is where it calls itself. And I'm not very good at these. I'll be honest. I'm gonna cheat and copy theirs. Never have been good at recursion. Probably never will be. I might be able to cheat now that I got this and make up my own. And it just destroyed all the formatting. So let me come here and redo it. Has to be indented. Okay, so let's run this. And if I was scanning triple quoted string literals. What in the world does that mean? Name is not defined. Yeah, what am I missing? Oh, that's not recursion. Um, to do recursion, it has to call itself. I'll probably end up writing an infinite loop. We'll try that. 1, 2, 3, 4. Okay, I'm doing n minus 1, so that's 5 minus 1. So I'm counting down to 4. So if I got blast off in the wrong place. Okay, well, anyway, this shows you recursion. The idea behind it is it calls itself. So, let me bring up Notepad so we can understand the flow of it. Okay, so we're calling countdown with n minus 1. Oops, that'd be 4. And so it comes in here. It says is n less than or equal to 0. It's not. So it comes down here and calls countdown again. So this is calling countdown with, since n is 4, 4 minus 1 is 3. Now it's not doing this print because it just immediately did another call. Countdown, then 2. Because again, n minus 1 and n is 3 when it back comes in. And again, it's calling countdown. So it comes up here, calls countdown. And this would be countdown 1. Not less than or equal to 0, so it comes down here and calls countdown again. Countdown 0. Now at this point, in this call, n is less than or equal to 0, which means it'll print blast off. Like that. Now after it gets done running this, it finishes the function and returns value back to where it's called. So it returns back value right here. Specifically, it was called right here, so it's going to do the next line of code. Now you might say, well, n has been changed. N is 0. No, it's what it was during this pass, where it's equal to 1. So it'll print 1. And after it gets done printing that, then it returns from where it was called from. And it was called countdown 2 here. So then it does this next one. And oops, n is 2. Prints that. And then 3. And then 4. Let's say I was wanting to calculate factorial. Let's see if I can do this. I'm not very good at these, I'll be honest. It's 1 times 2 times 3 times 4 times 5. And so fact equals that. Calculate factorial. Okay, so then I probably can fudge this since I already got an example to work with. It's less than or equal to 0. Then I want to return 1. Here, I want to call calc factorial. In -1, and then right here I want to answer equals calc factorial. Thought I was joking when I told you I wasn't very good at recursion. Okay, so what I want to do is 5 times 4 times 3 times 2 times 1. And this will return to 1, and then start the cascading going backwards on my recursion. But I don't think I want answer equals because it'll overwrite answer each time. But I could have answer initialized to begin with. That's the problem. What if I send and pass? And a pass is equal to 1. Then I want to set my answer equal to 1. So that initialize it. So we pass equal to 1. And when I call this, I want to call pass plus 1. So it won't be equal to 1 anymore. It'll be 2, 3, 4, and so forth. And then answer is equal to answer times that. And I'm returning something, so I need to return. I don't think I want that there, though. Where do I want it? Return 1. Return answer. If you never get recursion, don't stress about it. It isn't part of your everyday job as a programmer, typically. 13 years, I never had to write recursion. What doesn't it like there? Pass, invalid syntax. It is blue, almost like it's a reserved word. Local variable answer reference before assignment. Okay, let's see if the book has it. I'm usually pretty good about this. Screwing it up and going forever. Okay. Yeah, let's cheat even further. A lot easier than I was making it. Okay, let's copy this. Fact answer is equal to recursion factorial 5. 120. That's correct. Okay, let's talk about what it's doing then. And hopefully I'm not spending too long on this. Because like I said, I don't want you to stress out about this. Where would you have to use this? If you're writing system utilities. Like if you want to work on next Linux version, and you want to write a system utility to go through all the files and all the folders under a certain location. Since you don't know how many folders there will be, you don't know how many files there will be, you have to use recursion. That's the easiest way to do it. Okay, so I'm going to call recursion factorial. I'll call it RF for short. And I'll pass in 5 to begin with. It does this check here if n is equal to 1. It's not. Else, it does this. So it calls itself again. Specifically, the call is going to look like this. So it's going to call n, which is 5, times, and then it's going to call RF factorial 5 n minus 1, which is 4. Then RF 4. It's not equal to 1, so it comes down here, does a return, and it's going to call RF3. 4 minus 1 is 3. RF3, it'll call 3 times RF2, following the same pattern, same logic as what I just said. 1. And then down here, this is actually equal to 1. So it's going to return in. So it's going to return 1. When I say it returns 1, it comes back up here to its previous call, and just this part right here, it replaces the 1. And then you got 1 times 2, which is 2, but comes up here then when it does the return, it returns it right to here. So we'll do 2 times 1. When then it does the return, it'll come back up here and replace this with 3 times 2 times 1. It doesn't actually replace it with that calculation. It replaces it with 3 times 2 times 1, which is 6. And then, as this is doing the return, comes up here and replaces that with the value of 4 times 3 times 2 times 1. And you see how it's building the factorial. I know the general principle of it with factorial, but and then it returns that to my main program. Now, the general idea on this is you count down. I don't know if counting up would actually ever work. Probably would be some cases. But you have 2 conditions. One, at the very bottom, when you're done down to the last number, that's when you start doing your returns. And then the other one is where you're calling itself by reducing it by 1. Now that I have this example, I wonder if I can add all the numbers from 1 to 5. Okay, 1 to 5. I don't know what that is. Not sure what that one was. Let's do 3. 3 plus 2 plus 1 is 6. I got a times here. Okay, let me change that to plus. Then we get 6. Let's say instead of starting at 3, I want to start at 1 and go up to 3. Let's see if I can change it now that I've seen the pattern. 1, and then if it's equal to 3, and here I'm going to put in a plus 1. Okay, so I guess you don't have to go down necessarily, but you do have to think about how to do it. If you're increasing, this should be your largest value. If you're decreasing, this should be your smallest value. Anyway, that's recursion. Interesting graph. I think you have to import turtle on this, but I'm not sure. Well, we're ready for chapter 6 now. Let's see if there's anything over in W3 schools I need to point out. Let me grab a drink here. Indentation, LF, else we talked about. If you only have one statement X, you can put it on the same line as the if statement. So you see the syntax there. Boy, that's weird. I don't think I've ever seen this one or used it. Probably seen it, I just don't remember. If you have one statement execute, one for if, and one for else, you can put it all on the same line. So you put this first, and then the condition, and then else, and then the print. That's bizarre. I would expect it to print A to B after the A is greater than B, but obviously not. These are ternary operators. Other languages have that where you can put like an entire if-else structure in one line. To me, your idea of programming is to keep it simple. You want to be able to come in a year or 2 years later and understand what you're doing in the program. You want somebody else to be able to look at the program and understand it easily. You can have an and. There's an or also. And didn't have here, but you can have a negation. Example of that. if I'm checking to see if somebody's input between 1 and 10. So I'm writing a program where I'm going to ask them for input. And if they did that, then I'm going to call that recursive function up above, just as an example. So in my if statement, I can say if input is greater than or equal to 1, and input is input. If number is greater than or equal to 1, and number is less than or equal to 10, that answer is going to equal to add number. Else, invalid input. So if I run that, I like something. Input the number between 1 and 10. I don't have quotes on it. Let's try it again. There we go. And if I put in 3, that's a string. Number is equal to int number. I have to cast it to a number before I call this recursion up here. Guess I need to convert it right here. Okay. You can't compare a integer and a string. That's what they're telling me there. So I can get rid of this now. Notice how you can embed a function inside of a function. Or actually not a cast. You can put a function inside of a cast. Okay, so now let me put 3 in. 3. Oh, try to change this. Oh, that should be a plus. This should be a minus. Okay, that's better. Now if I put an invalid value, like 11, tells me invalid input. So that's the use of an AND. Now, how an AND works is this has got to be true and this has to be true. So when I plugged in 11, 11 is greater than or equal to 1, so that was true. But then when I plugged 11 into what I got highlighted there, 11 is not less than or equal to 10. That's false. Since both of them weren't true, then it failed and came down to the else and said invalid input. Now the OR is such that either one can be true if you want to use an OR. Input sometimes can cause your program to crash, and so you want to head that off and look for invalid entries. When you call a function over and over, calling itself, It uses something called the stack. Stack is like a I used to like to go eat Chinese at the buffet, but I haven't been to a buffet in probably 10 years for a Chinese buffet. And maybe when I went out to Vegas, I ate. No, I didn't eat a Chinese buffet, but I used to love going to Chinese buffets. When you went there, they oftentimes would have a stack of plates. The more fancy restaurants would have a place where when they brought plates out, they'd push it down and it'd be a spring. So it'd be a hole in the table, and it'd push the plates down. And when you wanted to get a plate, you reached down and got one, and it popped off. Well, in programming, that concept of pushing and popping applies to stacks. So you got your stack here. And when it calls add. When you call that function, and you're passing in, let's say 3. That puts it on the stack. What does it mean by putting it on, or pushes it on the stack? What's it mean by pushing it on the stack? Well, that means that it saves off values, other information it might need to know where to return everything to. And then we call it again. It saves off more information. Then you call it again, saves off more information. Now, when it starts doing the n equals 1 and does the return, it pops this off the top of the stack. Stack is a memory structure. So it pops that off. And that comes up. Then it pops this off. And that comes up. And then it pops this off. Well, with recursion, it'll keep on pushing things onto the stack, which means you can very quickly, depending upon how many times you call itself, you can have it overflow the stack. So, for example, let me try to blow up my program. That should call itself 2,000 times. Might not be enough. I don't know. There it is. Maximum recursion depth exceeded in comparison. That's not what the other program languages give you as an error, but basically overflowed stack. If you go to a Chinese restaurant and they're using that concept where they're pushing the plates down, they can only put so many plates on there. There's only so much room. Same principle holds true of the stack. Your hardware has only so much memory allowable for a stack. When you keep calling itself too many times, it'll overflow the stack. So anyway. Talk about the nested if. Pass. I never used that. That's the end of the if else there. Okay. I think next time we'll go into chapter 6. Really don't have much time to get into anything worthwhile there. So we'll dive more into functions and keep building our knowledge. I'll put an assignment out there using what we've covered today. So have a good day, and I'll see you next time.